what other use cases can Redis support apart from just being a cache?
Exactly. So Redis does a pub sub. So pub sub is like you publish a subscriber model in a chart systems, right? So you have TCP connections from client. You send messages you receive from a particular server, and you respond to the client, right? And it's very simple when you have single node, right? So you have whenever you have like multiple application servers and you have like multiple clients in front end, and they are connected to particular application server, right? For example, these clients. So whenever you, for example, there is a session going on. So you are attending a live class. People are chatting. You want to aggregate those chats in a single. For example, you want to build a room kind of thing, right? A real time room. So you are sending messages. So but this client is connected to this particular application server one. This client is connected to the particular 2, 3, 4. So how do you make sure whenever you send this message, right? This pass through this particular application server. But how do you make sure this particular 2, 3, 4, like all of these clients also receive these messages because you are connected to a single room? Just considering you are in a room, but you are connected to different application servers. Your messages are getting public. You are sending these messages over TCP to your application servers, right? So what you can do is this PubSub pay you can subscribe to a particular topic. So for example, this you have Redis. So every time someone is joining a room, you can subscribe you're connected to a particular server. The server can be subscribed to this particular Redis via Redis pops up. Okay. So what you can do is all of these servers are connected over a particular key. Let's say it's room 1. Right. So whenever you send a message, you can publish this message to this room. And this particular pops up mechanism, every server is subscribed to Redis, right? So this Redis can publish this message to all of these servers, Now from this server, you can send this message to all of its clients. Basically, these clients are connected to application server, different application server, but they are aggregated in a Redis PubSub mechanism. A room is created in Redis in memory. So every time you're publishing a message, it is actually published to this particular room, a key, and Redis is publishing or to all of his subscribers. Upon receiving this message, you can send all of so basically this application can get all connected clients and publish this message to its particular clients, and this get all active clients can be get from all of the application servers.
Okay. So, but in this, will order be maintained, like the order messages which is being sent? Is it possible?
Ordering is something, obviously for a particular key, the thing that I've observed is for a particular key, Redis is for a particular key, Redis is bound to a single thread, right? So for the IO is limited. Basically, in Redis 6, IOs are threaded now, disabled by default. But Redis receives these messages in an order for a particular key. You can still have the ordering.
Okay, for a particular key. Okay.
You can still have the ordering anyway because you are operating on that particular key. It's atomic anyway. So you are receiving these messages. You have these order maintained. Also, because it's not persistent though. PubSub is not persistent. It does not store what all messages it got. So, for example, the client was down at that point of time. When it's up, it does not receive that message. Doesn't have a replay. It's not a drop-in replacement for Kafka. But we can talk about. So basically, then we'll talk about if you need persistent, you have Redis streams. Okay. Exactly. So Redis PubSub does not have persistent. So it's just real time. It just publishes it and forgets about it.
Okay. So once everyone has got it, it just forgets about it.
No. So basically, it gets the message, it publishes it. But if the server does not receive this message, or not, don't care. It just publishes it, but server has to receive it. But just that it publishes it, it acknowledges that it published it. Message has been published. But for example, while basically receiving the message, the application server got down.
Yeah. So in this case, we can introduce some kind of DLQs or something like that. Like if the message is somehow not received, then it will go to a DLQ or it failed processing.
We can do that. And also, people usually do this only. For example, you need whenever for example, you have a room in a real-time class. For example, you are attending a live class for a particular, there is a platform, let's say XYZ, and you have a chat in between. For example, Google Meet, you have chat. So you are typing messages. Whenever you refresh something, you still, for example, Google Meet does not maintain the state whenever you refresh.
Refresh the page.
Doesn't have, but usually in chat platform, if you want to maintain this state, you have to maintain this in a persistent store as well. You can use Redis as well. For example, you can have a list which contains all of these in a sequence manner, right?
Got it.
So whenever you refresh, you can just replay those lists, right? Or one of the ways to implement DLQ is Redis stream as well. We can discuss about Redis streams. So Redis streams, it operates in memory, but you can consider it as the way Kafka works. You have publisher and subscribers. So it stores this data. Consider every data as a stream. So just that you can, for example, you can have n number of consumers. You have a stream called room, chat room. Okay, we can consider it as topic, right? So for this particular topic, you can have n number of consumers for this particular topic, reading messages in its own order, right?
Okay.
And also there is no such thing as committing messages. If you are coming from a Kafka background, you have to trim these messages once you are done. Basically, whenever you push a in a stream, in a Redis stream, whenever you push a message in Redis stream, it stores the timestamp in millisecond. So for example, you can range query on millisecond inside Redis stream. For example, you need data from 1:56 to 2 p.m. You can just do a range query on streams and also trim that stream once you read and persist it somewhere.
Okay. So for how long this data is maintained in the stream?
Basically, you can have it's not based on timestamp. It's based on the number of streams that you want to maintain. So for example, you can have 20,000 streams at a time. For example, whenever it exceeds 20,000, it's just going to be chop off the older ones.
The older ones. Okay.
Exactly. So Redis streams works in that way, but it's memory. In memory operations, everything is in memory.
Yeah. And deploying this in like different fashion, like Redis as a pub sub or a stream or as a cache, how tough is it for, like, suppose if someone has to do?
Actually, it's saying Redis comes with by default only. Redis streams, pub sub, and we'll talk about sorted sets. You have geo indexes. Everything comes up in a single, like the open source one have these modules by default.
And you just have to start up these modules in a host and just host it.
Basically, not modules. Redis does have different modules. Redis does have search module, JSON module. You have like AI module. Those are like different modules. For example, initially we discussed, right? JSON, we store JSON as stringified version of JSON and store it as a key. But Redis has a JSON module introduced as well. You have to add the JSON module so that you can do a drop-in replacement of JSON. For example, you get a JSON and you directly insert into the JSON module. Okay, you don't have to do the stringify operation and everything, right? So those are modules. You have to add it yourself, but just by hosting Redis, you have like a ton of data structures by default. You have Redis streams, pub sub, sorted sets, a list. You have hash set. You have hyperlog logs. Those are like by default comes with Redis. By default comes with Redis. So for example, sorted set, and I'll tell you, like, people power their real-time leaderboards with sorted sets. So with sorted set, you can you have a key, you have a score associated with that key, right? So every time you do a operation, you do an increment operation, or you set operation, basically ZAdd is the operation for, or zincreby. So basically you do an increment operation. It basically real time do a ranking of all of these keys, basically, right? For example, in leaderboard, you need real time ranking. Every time there is a score increment, you want to real time do the ranking.
So, but how does this happen in a distributed manner? Like if the data is divided in slots?
That's what we'll discuss. That's a very interesting question. And the thing is, for a particular sorted set will only be limited to a particular slot only.
Okay.
So why do I mean by that? Because like for a particular slot, it will be leaderboard 1, the main key, leaderboard 1. Inside that you have user keys in the sorted set, right? So now why I came across this, Redis I will discuss a very specific use case that in a production environment people faces this is a pipelining. So pipelining is a way for Redis to send a lot of commands in a single network hop. So you can pipeline a lot of commands. For example, you have like 1,000 write queries you want to perform, right? For example, from a database, you have a job, you have like there a cron job which is running. You are caching a lot of information in an interval. So every 5 minutes you are doing a lot of like, let's say 1000 user ID have to cache data for, right? So Redis provides an ability to send these commands in a single hub. You don't have to do 1000 network calls to Redis. In a one network call, you can do pipelining, and it will entirely do this operation and return, hey, this operation has been done. Okay. So the issue is, if you have a cluster, right? And in a single cluster also, you have like multiple hash slots, right? So for a particular key, let's say you have a key, my user ID is 123, and your user ID is 456, and I have the key stored as user info. This is the key name, user info 12456 user info. Okay, so whenever you do a set command, right? Set command, let's say my hash slot is 4357, and 456 your hash slot is 5257. So now because of this, our hash changed, right? Because we have different user IDs altogether. So now if I fire a pipeline in a distributed manner, you said, right, how do you like do this operation in a distributed manner? I'm just talking about this. For example, you do a pipeline, you want to send these commands in a single hub to Redis. Redis will throw an error. Hey, there is a cross slot error. That means Redis will say these two commands belong to different hash slots. So you cannot do pipelining of these commands. Okay. So for example, you have an operation has to be across basically multiple hash slots, right? You have to ensure all of these keys belong to a single hash slot. Okay. Every time you do any operation, this is a batch operation, right? So how do you do that? You can also tell Redis, hey, please store these key in a single hash store. How? By notifying Redis, key, this is the curly braces. That means compute this hash on user info. Whenever you just attach a curly braces, starting of the curly brace and ending of the curly brace to a particular string, and Redis will identify that, hey, the client wants to compute the hash on this particular part. I won't be computing the hash on the entire key. Instead, I will compute the hash on user info. So both these two keys will return the same hash slot. Let's say 4324. So now both of these keys are stored in the single hash slot. So every time you do a pipeline or batch operation, it will happen. So you can also enforce these. Like you need to know this technique so that while pipelining, you are actually like telling Redis, hey, just compute this hash on this particular portion, not the entire key.
The best way, if someone has to learn Redis,
you just search for Redis documentation in Google, and the first thing it will come up is Redis data structure, data types. You just directly jump in and just locally install Redis, and directly they have examples for each of the data structures that you have, right? So you can start learning from there itself, all of the modules, at least not from internal perspective. Once you have these modules at place, you can start learning how Redis internally do all of these operations. I think we can jump into the anatomy of a Redis command. Basically, we covered everything across Redis, and like the high level design, the commands that is executing. Specifically, we can talk about whenever you fire a command, right? So how it goes to Redis server, and how it's getting written, when it is getting written, and how Redis is limited to its throughput. So let's say you have this client, and it's a Go client or Node client, right? And you fire a particular command. Let's say set name equal to Sukat, right? So you have this server, right? This server, and we can just consider it as a Redis server. So you fire this command to this giant server, black box right now, and what happens is Redis is like everywhere. You just learn that Redis is revolves around this single threaded event loop, right? So what this event loop does, like Redis does have separate different threads as well, but it mainly revolves around this single threaded event loop. What this event loop actually does is it actually responds to input and output events to the file descriptor specifically. Okay. So it's a way of thinking about file descriptor is a way to represent input and outputs, right? So it's a way of thinking that whenever your client sends some data to Redis, right? The kernel will notify Redis, hey, Redis, there are some data that is like ready to be read, right?
Okay.
Kernel will notify Redis. It's like, this is the way file descriptor works, right? So we can consider it as key. This is the server entirely. This is the server, and you have the kernel.
Okay.
Kernel input buffer and output buffer. Input buffer and its output buffer. And you have the basically Redis client, right? You have the client input buffer and output buffer. Client input buffer and output buffer. So basically everything is an IO, right? Everything you do a stick or a write, it's the IO operation, right? So we can consider as kernel have input and output operations, and Redis client does have input and output operation, basically input and output streams, and you have your basically command stores, basically command list, and you have this AOF and everything, AOF for persistent and all in Redis client. So every time your client sends this command, it's a byte string, right? And it's a /n at the end to identify that basically it's the end of the command for Redis to identify that. Okay. So whenever you fire this string, kernel have this data, this input stream stored as an input stream. So now kernel will notify Redis that, hey, basically read query from the client. So the first stage is key. What Redis does is read query from the client. So it takes this query and actually moves this to the input buffer inside Redis client. So once it receives this inputs, basically this stream, input stream from to Redis input stream. So what it does, it actually try to process this input buffer. So once it receives this byte string, it tries to identify, hey, well, this is the input buffer. I want to basically takes this arbitrary string and try to convert it to a particular format that it can execute, right? So for till now from kernel, it does not mean anything, right? Set name, there's nothing. It's just a byte string, right? So it receives this arbitrary string. It tries to process this input buffer that it received from the kernel, right? So now it tries to, once this like converts this particular string to, basically does have a /n at the end to identify the end of the string, and it divides it in such a way, like you have like spaces and everything, and it constructs it to a particular format, right? To a query, like it was actually sent, yeah. Exactly. So now it tries to process command. So what it does, this process command, it tries to identify, basically they text this command, like if you go to Redis source code, I told you, once you learn Redis, this data structure and everything, you try jumping into the source code of Redis, which is very readable code. And it's once you go to the server.c file, it's written in C. If you go to server.c file, they have like a giant list of command in that file. Okay. So what it does, so once you process this buffer, it goes there and just see what kind of command is this from the server.c file. It goes there, it just validated, it's a set command, and this set commands expects like a key and a value. It can have expiry as well, but in this case, you don't have an expiry. It's an optional parameter, right? Okay. So it just validates that, hey, this command is valid from the servers.c file, and construct this command. It just validates it, and also it checks a lot of validation. For example, so let's say you SSH into this Redis instance. You have like 4 primary instance, 3 primary instance, and you actually go to, like you went there, you connected to this is a primary 2. You connected to primary 2 by yourself from local, and you try to basically execute a command. Let's say set name Sukhad, right? But name's hash slot is belonging to P3, but you are executing that command by yourself in P2. You can do that, right? You can do that anywhere, right? Right. So it will throw it won't throw an error. It will just move that command to P3 and execute it. Okay. The Redis is built in such a way that it also checks whether this command in this process command phase, right? It also validates whether this command belongs to this particular node or not. Exactly. Once it like validates everything, then it actually executes this command by calling a call. Basically, call is actually executing your command. So once it executes this command, for example, this is the server.c file. Basically, basically command handler. Command call is basically calls the command handler. What this command handler does, it actually executes this command. And for example, for this set name Sukhad command, you receive from Redis the usual format is okay. Once it's like succeed, you just receive a okay string from Redis. Hey, it has been executed properly, successfully, right? So this okay has been written to the output buffer. Okay. Of Redis. You have input buffer, you have output buffer. Input buffer, see this command went to all of this validation and this is written to the output buffer.
From where the client reads.
Exactly. So your Redis client, no. We haven't even we have from the kernel, basically the way everything works in system is, so where you receive the data, you have to return that data to there only, right? For example, from the kernel, we received the data, you have to write it to the output buffer as well, right? Because kernel output buffer has not received the data. Now the data is at after the command, basically command handler stage, the data is at Redis, the Redis clients, like the internal Redis servers client buffer, client output buffer. It has been written into output buffer. The way Redis works is, it does not, once it executes the command, it does not return to, hey, I have written this command. It does not do that, because every time you do this input output operation, this write operation, these write operations are like actually system calls, right? So Redis tries to minimize the number of system calls is trying to do. So from this particular output buffer, so it tries to do it in a batch manner. So what it does, it every time. So what happens is, whenever you start the Redis server, you started the Redis server. So what it does, it calls a epoll function. Every time you start the server Redis, so you self-hosted Redis, you start the Redis server, it calls a epoll function. It goes to after sleep. It goes to after sleep and executes basically process events. And once the process event is done, it goes to before sleep. And then again epoll. Basically, the event loop is working like that only. Epoll, after sleep, basically because it was sleeping, it just got woken up. Goes to after sleep. Basically, once it woken up, what processing is doing, right? Event loop is doing all of this processing, like the entire reading from the input and everything. But once it is written to this output buffer, before sleep is getting triggered, what it does, basically there is a functionality. Basically, I'm talking in terms of functions. For example, I called a function read query from client, process input buffer, process command. These are actually actual functions inside Redis, internal Redis. So what it does, it calls a function called handle clients with pending writes. Handle clients with pending writes. So that means, so whichever commands has been there in client output buffer, these are pending writes, right? This has not been written into kernel's output buffer, right? It has not been written to our this client, like Go or Node client has not received the acknowledgement yet. Okay. Execution has been done, but it's still in the Redis output buffer. It has not been written to client kernel's output buffer. So what it does, before going to sleep, right? It calls this function handle client with pending writes. So it checks like everywhere, like what are the pending writes that are received that has to be written. So before going to sleep, it writes to the kernel output buffer and goes to sleep. But Redis try to avoid these, at least from a specific point of view, like to return it to the client. Maybe the execution has done in 50 milliseconds, but the data is still there, has not been written. For a client, it can be 100 milliseconds. But for a Go client or Node client, the command can be received in 100 milliseconds because it has not been written into kernel output buffer yet. Right?
Okay. So, but when we are implementing the client, so generally we wait for till we get the output, or we keep processing and we don't wait like in asynchronous manner.
In gate, you have to wait, right? Otherwise, you cannot return. So basically, this won't be delayed. Just that like the way it executes it, does it in a batch way.
Got it. Very fast. Okay. And we can change that interval also to our needs. Oh.
If you're interested, you can file hosting it. You can directly change from the Redis source code and do it yourself. Yeah, you can do that. But once you have open source code, you can build on top.
Yeah, you can do anything with that.
Exactly. You can have configurations as well. So just that these IOs in like after Redis 6. So these IOs like process commands, this valid process command, what it does the validation, right? So these validation can be can be done in a threaded way. Like it does uses multiple threads. You can enable it by yourself after Redis 6. Multiple threads. So, you have other threads as well. For example, delete. Well, all of these operations are synchronous. For example, you are deleting a key, right? So it is synchronous operation. So there is there is a operation called unlink. Redis provides you asynchronous operations as well. For example, instead of delete, you can do an unlink of the key. So it uses a separate thread to delete your keys. So for example, your getting and setting can be done in a single in the main thread. But delete should be avoided because you are anyway discarding this data. You should not block the main thread because you are deleting something. You can unlink the data. Unlink uses a separate thread. It just basically unlinks the value out of the key and later flushes the data.
Deletes it, got it.
This is pretty much how it works. This is just a simple cycle. If you just just wrap around in this head, every time something is getting executed, you just remember, I started this, epoll is happening after sleep, process event before sleep. This is the entire life cycle of Redis.
Got it. Yeah, I think this was really helpful to understand like internal details, like how it is happening. I don't think someone can easily figure this out until reading the code is very important in this case.
Exactly. You can just directly search these function names inside Redis code base. You can directly find that how handle client with pending writes, like how it works, everything is written in C, very readable code, revolve around like these 2-3 files.